We're trying to figure out what the determinant of the Jacobian matrix is for these two equations. In order to do that, first we'd want to analyze this situation that we have here with these cosines and sines, and we can make some quick adjustments because we should know that cosine of pi plus v, once we see any kind of addition or subtraction of these pi's, let's look at our sheets and try to find out what that would equal to in a simpler form. I think that would be negative cosine of v. So we can actually replace this by saying x equals negative u cosine of v. And over on this side, we'll take a look at the sine. But I can rewrite this as saying sine of like negative pi minus v. And then I would have this, which is kind of like saying sine of negative x, right? And if we have the sine of negative x, we should know that's actually equal to sine of x. So going back to this, technically negative sine of 11 minus v is what we have here. And if we try to look at what the, sorry, not 11, but pi minus v thing situation is here, if we go and look at it in a little sheet, see that that equals negative sine of v. So we can make this little adjustment here. Say negative u sine v is what we have right there. Now we can go ahead and take our derivatives. So we'll say dx equals, and I guess so here we'll get negative du, and then we could try to leave that the same, and then we'll go ahead and add a negative u, and then we'll try to take the derivative of the negative cosine, which would be, I think, a positive sine. So technically you get a positive sine v, then delete the positive signs. And then we go, so we got our dx, and we'll try to figure out what the dy is. Also, don't forget the dv on that side. Dy is negative du sine v. And then here we can go ahead and add the derivative of negative sine is still going to be negative, so I guess we'll get negative u cosine v dv. All right, so we'll be able to set up our little matrix by saying dx dy equals negative cosine v, and then we get u sine v, and then we have negative sine v, and then we have negative u cosine of v du dv. So take the determinant of this little matrix, and we'll get sort of u cosine squared v plus u sine squared v, and that would just be u. So in the end, we just basically get dx dy equals u times du dv. And there we go. Not too bad.